So we want to prove now, we want to prove that the cut, of y minus the cut of x. This is module 2 now, question 3. The cut of y minus the cut of x over the sine of y. Well, that's not sine, that's cut x over the cut of x over the cut of x minus the cut of y. That's what we want to do. Okay, and we want to prove it. So this is the left-hand side, of course, LHS. This is our left-hand side. Always start with what your left-hand side is. You want to do this proof. When you start with your left-hand side, you expand out this right here. So let's expand it out. When you're expanding this, cut y, remember cut is cos over sine. So this is cos y over sine y minus cut x is cos x over sine x. And all of this is being divided by cut x is really cos x over sine x. Cos x over sine x minus cos y over sine y minus cos y over sine y. Now that we do that now, this is going to be equal to, simplify what is this now. To simplify this numerator, we multiply up the sine and multiply up sine y, multiply up sine x, multiply up sine y to write all of this as, this is now sine x cos y, sine x cos y minus cos x minus cos x sine y, and all of this is being divided by sine y sine x. Sine y sine x. Now since this is what we're dividing by, all of this again will be divided by, join this as one fraction again, joining it as one fraction, it's going to be sine y cos x minus cos sine y cos x minus cos, cross multiply sine y cos x minus cos y sine x minus cos y sine x, and this is being divided by sine y sine x. All right, nice and easy. So what do I do now? This is then going to be equal to, now whenever I have a fraction divided by another fraction, I like to rewrite it another way that it is easier to understand. I'm going to rewrite it as sine x cos y minus cos x sine y minus cos x sine y, and all of this is divided by sine y sine x. Nice and easy. And it is divided by, since you're dividing by this, it's the same as multiplying by the reciprocal of this. And the reciprocal is going to be sine y sine x over all of this, which is sine y cos x minus cos y sin x. Nice and easy, soft. So what happens? So this sin y sin x cancel each other. And so we're left back now with this. We're left back with just in the numerator. We're left back with sin x cos y minus cos x sin y. And all of this is being divided by your sin y cos x sin y cos x minus cos y sin x. This works out to be equal to, when you have sine then cos minus cos sine, that is just the sine of, it's just the sine of x minus y. It's just the sine of x minus y. And this one is just going to be the sine of y minus x. I'm positive that's what we have there. This one is just the sine of y minus x. All right, now let's see what happened. It says that should be, okay, I see what happened. Throughout this whole time, it was a plus. I had a minus here. There should be a plus. There should be a plus in the denominator, a plus in the denominator. So when I flip it, this is a plus, this is a plus. Okay, no issue. So now we prove it. Should be an x plus y. So now we prove it easy, soft, which is equivalent to our right-hand side. So that was an easy question. Let's go to the next part. The next part says, hence or otherwise, find the possible values of y in the trig equation when that is equal to 1. So straight away, we know it that if you're going to be solving the cotangent, if you're solving that the cot of y minus the cot of x over cot y minus cot x over cot x plus cot y. If you're solving this now, if you're solving this and you're solving it equal to 1, then pretty much what you're solving is that this implies that what we're solving is sine of the sine of x minus y over sine of x minus y over the sine of x plus y is equal to 1. All right, so that implies we can cross multiply the sine of x plus y to get that the sine of x minus y is equal to the sine of x plus y. This is what we're solving in reality. Sine x minus y is equal to sine x plus y. So you can expand out what all of these are. Sine x minus y is just going to be sine x cos y minus cos x sine y, and that's equal to sine x plus y sine x cos y plus cos x sine y. That's what we're solving. So if this is what we're solving, what can we do? What can we do? Let's think about it. Now, as we can see, we're solving this. All right, I have a sine x cos y here. Let's see what I can do. So if we bring over this, we're going to have sine x cos y. So sine x cos y cancels on both sides. Luckily for us, it cancels. If we subtract sine x cos y from both sides, we're going to actually see that we're just getting minus cos x sine y is equal to the cos of x sine y. And we don't even need to do that because they said that we should use sine x as a half. So we don't even need to do that. We can replace sine x with a half. Sine x is a half. So this is really a half cos y minus cos x. And now look what I'm going to do. Before I even go any further, I'm going to draw a triangle. All right. It's always easy with a triangle. If I draw a triangle with the angle x, the sine of x is opposite 1 over the hypotenuse 2. And so what that is telling me, if sine x is 1 over 2, then that is telling me that the adjacent is 2 squared, which is 4, minus 1 square rooted. So the adjacent is working out to be the square root of 3. All right. And so if that is the case, then what that is telling me then is that cos x is then telling me that cos x is equal to root 3 over 2. That's cos x. Cos x is root 3 over 2. So now we can do some substituting. Cos sine x is a half. Sine x is a half times the cosine of y minus cos x, and cos x is root 3 over 2. So root 3 over 2 sine y. And that's equal to sine x. Sine x is a half. We have a half cos y plus cos x again, which is root 3 over 2 sine y. First thing I want to do is multiply this equation through by 2. I don't like to be seeing so many half. If I multiply through by 2, I'm going to get that cos y minus root 3 sine y. Let me put what I did right here. I multiplied through by 2. By multiplying through by 2, we get rid of that half in the denominator. And so what we end up get is cos y minus root 3 sine y is equal to cos y plus root 3 sine y. Now the cos y's are going to cancel clearly, right? If I bring cos y over here, cos y minus cos y becomes 0. Then if I bring over here the root 3 sine y over here, root 3 sine y, bring it over here, I'm going to get 2 root 3 sine y, 2 root 3 sine y is equal to 0. That's what I'm getting. 2 root 3 sine y is equal to 0. Now that I get that 2 root 3 sine y is equal to 0, I can divide by 2 root 3. And so then that means that sine y must be equal to 0. And if sine y is equal to 0, then that is telling me that y is equal to 0, or y is equal to pi. Those are the two answers. But the question told me that, remember they said that x is between 0 and pi by 2. So from this, yep, these are the two possible values. All right, 0, 2 pi. Let's see if there's any more possibility. If we go around the circle one more time, we can also get 2 pi. So these are the three solutions. All right. So we can conclude, therefore, y is equal to 0, or y is equal to pi, or y is equal to 2 pi. All right. Nice. And you can actually test your answer and test it. We know that x is sine inverse of a half, which is pi by 6. So x is pi by 6. Try a value like y is 0. So if you have the sine of pi by 6 minus 0, this side would give you the sine of pi by 6, which is the sine of 30. Sine of pi by 6. This part is a half, and try this. This is good. Try when x is pi, when y is pi rather. Pi by 6 minus pi is going to be minus 2.61. Take the sine of that value. You get minus a half. Check it if you get the same over here. So pi plus pi by 6. And I'm getting the same. So these are the possible values of y. Y can be 0, pi, and 2 pi. Nice and easy. Soft. Let's go to the next part of the question. Next part of the question says, f of theta is 3 sine 2 theta plus 4 cos theta. And it wants us to express it in the r sine form. Let's go ahead and do that. It says f of theta is equal to 3 sine 2 theta plus 3 sine 2 theta plus 4 cos 2 theta. Nice and easy. That's f of theta. F of theta is 3 sine 2 theta plus 4 cos 2 theta. So if this is f of theta, right, and we want to express it in the r sine r cos form, the first thing is r is going to be equal to 3 square plus 4 square square rooted. That's r. And so that works out to be 5. And then theta is going to be equal to tan inverse of b over a. So theta is tan inverse. Theta is tan inverse of 4 over 3. So you put that in a calculator. What's tan inverse of 4 over 3? That gives you this value here. Tan inverse 4 divided by 3, that's 0.927. So what does that mean? That means then that f of theta is equal to r, which is 5, times the sine of 2 theta plus alpha, and alpha is 0.927. So 0.927. Nice and easy, soft. Okay, let's go to the next part of the question now. It says, hence or otherwise, determine the value of theta between 0 and 2 pi, at which f of theta is minimum. So they want when f of theta is minimum. All right, so let's find minimum value. Value of theta for which f of theta is minimum. Now, first thing I want to tell you is that f of theta is always bounded between r and minus r. This is part 1 answer. This is part 1. Right? That's in that form. And this is part 2. This is part 2a. So first thing, f of theta is always between 5 and minus 5. That's the first thing we need to know. It's always bounded between 5 and minus 5. Now, f of theta is equal to 5. F of theta is equal to minus 5. It's equal to minus 5 when is sign going to be negative? We know that the sign of an angle is negative. If I were to call all of this x, it is negative when the sign of 2 theta, all right, let me write it better. F of theta is equal to minus 5 when the sign of 2 theta plus 0.927 is equal to negative 1. All right, that's when it's equal to minus 5. And so we need to solve for theta in this case. So first thing we're going to do is take sine inverse to get that 2 theta plus 0.927 is equal to sine inverse of negative 1. All right. So sine inverse of minus 1, you're going to get minus pi by 2. So you're going to get sine inverse of minus 1 is minus pi by 2. Of course, generally you get 2 answers, right? You want when theta is negative, all right? Generally they tell you to draw a circle, and they tell you that sine is negative. Sine is negative in the 3rd and the 4th quadrant. And then you find the principal acute angle in the 1st quadrant, which is pi by 2. And so then it's going to be pi plus pi by 2. And so some people actually write pi plus pi by 2. Some people actually write pi plus, oh gosh. Let me see if I can get that back. Yeah. So in the 3rd quadrant, as we said, the angle is what? In the first, it's pi by 2. The second, it's pi minus pi by 2. In the 3rd, it's going to be pi plus pi by 2 when it is negative. And pi plus pi by 2 is 3 pi by 2. All right, so this is 3 pi by 2. That's one possible answer. Or, yes, or. You're wondering where the or comes from. Or it can be 2 pi minus pi by 2. 2 pi minus pi by 2. And 2 pi minus pi by 2 is 7 pi by 2. So let's solve for theta in this case now. Let's start with the first one. With the first one, we're going to have 2 theta is equal to 3 pi by 2 minus 0.927. 3 pi by 2 minus 0.927 is 3.78. So this one is working out to be 3.78. Then you divide through by 2 and you get theta is equal to, and you divide that by 2, you get 1.89. That's one possibility, 1.89. And this is in radians, or the next answer would be 2 theta is equal to, you work out what is 7 pi by 2, 7 pi divided by 2 minus 0.927, and the other answer is giving me 2 theta is 10.1. And so this answer is giving me theta is equal to 5.05. But this answer is not valid. Not valid. Not valid. And this one is not valid. And the reason for that is because they told us, remember they told us that theta must be between 0 and 2. Theta must be between 0 and pi. Wait, actually this is fine. This is fine. It's between 0 and 2 pi. So those are what you're getting. Theta is either 1.89 or this theta is 5.05. If you don't believe me, put it in the calculator. 3 sine 2 times 1.89. 2 times 1.89. 3 sine that. Plus 4 times the cosine of 2 times 1.89. I get my -5 for this. I'm putting 5.05 as well. You get 3 sine plus 4 cos. I get my -5. So both of these are fine. These two are the answer actually. These two are the answers. All right, any one of them is fine. All right, 1.89 and 5.05. I know it says find the value, but both of them satisfies it. Now it says determine the maximum and minimum value of 1 minus 7, 1 over 7 minus f of theta. So let's do the final part of this question. So to do the final part of this question, first we have to start with by saying f of theta is going to be bounded. It's bounded between 5 and -5. We know this. Good. So if I were to say minus f of theta, if I multiply through by -1, that's bounded by 5 and -5. All right. And then if I add 7 to both sides, I would get that 7 minus f of theta is bounded by, add 7 to 5, I get that it's bounded by 12. And I add 7 over here, it's bounded by 2. I then reciprocate it, I flip it and reciprocate it, and I get 1 over 7 minus f of theta. And that's bounded by, that's going to be bounded by 1 over 12. And this is 1 over 2. Nice and easy, soft. So then the question you may ask now is, what is the minimum value of f of theta? So you can just say, okay, the minimum value is, the minimum value of that is going to be 1 over 12, and the maximum value is a half. That's how you do that question. Nice and easy, soft, no issues. That takes care of question number 3. Nice and easy. All right, we're on to question number 4. On to question number 4. Question number 4 says, let L1 and L2 be the diameters of a